let us look at the horizontal and vertical component of a vector. The horizontal component means from side to side, and that's also called the x component. The vertical component means the rise and fall, up and down, and that's the y component. And that vector can be written in the form of a column matrix, which is called the column vector. So let's take a look at an example. Suppose you have a vector, say from here, and it goes here. Let me just kind of fix this up. Let me make it thicker. Okay, nice. So let's say this is vector AB. All right. Now, if, for example, this was a case of you walking along a road, and this is you, and you walk this way up from A to B. Now, you start at A and end at B. However, you could very well have walked from A and gone straight across. Want to try and make this straight. Okay. All right. Then turn the corner and head straight towards B like that. So you go this way, and let me just kind of erase some of these things here. Fix this up a bit. And then you go this way. Now, we're looking at A, starting from A and going straight to the right. We go 1, 2, 3, 4, 5, 6, 7 to the right. And this is X. You know, the horizontal axis is the X axis. 7 to the right, and 1, 2, 3 upwards. And this is Y, all right? What we can say, if this is vector AB, we can say that vector AB is written in the form of X, Y. That's our column matrix, referred to as the column vector because it represents a vector. So AB in this specific case is equal to, how far did I say go to the right again? 1, 2, 3, 4, 5, 6, 7 to the right. 7. And it goes 1, 2, 3 up. So vector AB is really 7, 3, where the number at the top in the first row is always the horizontal or the X component of the vector. And the number in the second row, that's the number below that, represents the Y component of the vector. Alright? So, there you have it. One example of our vector divided up into its horizontal and its vertical components. Alright? Now, let me erase some of this thing that I have here, and let's imagine that vector AB is now like this, and I want to write down the values, horizontal value and vertical, for vector AB. Now moving from A to B, say I move this way, I'll have to move 2 down and how much across? 1, 2, 3, 4, 5, 6, 7 across. So the x component is 7 and the y component is 2 downwards. So what I will have to do is the x value is still 7, but the y is now 2 and it's going downwards. So I should have a negative 2. So this vector AB can be represented like this. So this is, remember, this is at A, this is at B. What this is saying is to go from one end of the vector, from the start to the finish. Instead of going straight across the vector, straight along the vector, you could go 7 units to the right and 2 units down, and you end up at the same place. You're going from A where it starts to B where it finishes. You could just travel straight across here and end up at B from A. But you could have gone 2 down, 7 to the right, and you still end up at B from A. So that's what the horizontal and vertical component here do. Let's make another change to this thing. Suppose instead of this vector now, what we have is this, and we're moving from A to B. So moving this way, we have A up here, you can see it, but it's a bit small, and B here. How do you represent this using its horizontal and vertical components? Well, from A, you could just go straight towards the left until you're above B. And when you're above B, you turn the corner and go straight down to B. And remember, at all times, this angle is 90 degrees because you're looking at the angle between a horizontal and a vertical. So now, horizontally, you would have to move 1, 2, 3, 4, 5, 6 units. So the x is 6. Notice now that it moved from right to left in the negative direction. So it's a negative 6 here. And then you have to move down. How much? 1, 2, 3 at B. So you move 3 down at B. So it's 3. And the fact that you're moving down means you have a negative 3 there. So what you have for the column vector, which is a column matrix used to represent this vector, is negative 6, negative 3. It is in the form x, y, where x is negative 6 and y is negative 3. So it is negative 6, negative 3. What this is saying now is that you could very well move from A straight to B like this. But if you start from A and move 6 to the left, 1, 2, 3, 4, 5, 6 to the left, then down 3 units, 1, 2, 3, you end up the same place, right? You end up the same place. Let's look at one more scenario we have here. Suppose we, let's say, have this situation. That's the situation we have now. It's going to change, so let me erase these things here. And we start from A and end up at B. So we are going this way. This is a vector AB. How do I write this into its horizontal and vertical component? Well, certainly, you could very well move from A straight along the vector up to B. But it's useful in many cases to divide it up into its horizontal and vertical components. Now, horizontally, from A to B, we're in horizontal at first. 1, 2, 3, 4, 5, 6, 7, 8, 9. You move 9 to the left. So it's negative 9. And then you move 1, 2, 3, 4, 5 upwards. It's 5 and it's a positive 5. The y is 5 and it's positive. So what you have here is a negative 9, 5. Alright? It means you move from A to B. If you move from A, 9 to the left and then 5 upwards. Alright? You could very well have moved 1, 2, 3, 4, 5 upwards first, then 1, 2, 3, 4, 5, 6, 7, 8, 9 to the left. You end up at B just the same. Alright? Now, suppose let us look at this situation. You have A, B, this vector. What would be the horizontal and vertical components of this vector? What would it be? Here, you move from A to B. 1, 2, 3, 4, 5, 6, 7, 8. Let me be careful here. Move 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 to the left. So what you have is a negative 10 for x, the horizontal component, negative 10. What about the y component, the vertical component? Well, there was no up nor down movement as you move along the vector. You did not rise, you did not fall. So the vertical component is 0. You see that? It is 0. Alright, just one more now. One more look at this situation. Suppose you have a situation like this. You have A down here and B up here. What would be the horizontal component as you move from A to B? Well, you can only get a horizontal if you shift left or right. Let's see what happened. Oh, you're going straight up. I'm not moving to the left or the right. There was no shift left or right. So the horizontal component was 0. Alright? So it is 0. What about the vertical component? Let's see. Did you move vertically? Oh yes, you did. How much? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 upwards. Positive direction. So what you have is a positive 13. Positive 13 because you're moving up. From A to B is up. If it was down, it would be negative 13. But it's up, so it is positive 13. So those were some examples of some vectors where we wrote as a column matrix or column vector, showing the horizontal and the vertical components of those vectors.